Welcome to the stream. Going live on YouTube. As you can see, we are doing Kickstart round B, the one from like a day ago. We have 4 problems, and from this you can guess that the stream should be perfectly around half an hour, plus time to explain stuff, so up to an hour. Wow, that's one very active chat. I think that might be the biggest ratio of number of highs in the chat divided by the number of viewers. Good leak. Good leak to you too. From now on, I will not wish people good luck in a contest, I will wish them good leak. Able to solve 2 questions? Well, I'm sure that at some point in the past I was also able to solve only 2 problems in such a contest. I'm just running Ubuntu in order to be able to code. I'm using, is there nothing private key? Yeah, I'm using Oracle VM VirtualBox. Just one thing. Need to hide this. Show you that. And I need to create directory, then I'm good to go. There are 4 problems. The time is time of last submission. It's not sum of times, and there is 4-minute penalty for every wrong submission. Those are, I think, the rules. At least that's what it is for Google Code Jam, but I think that Kickstart is very similar. Now the link will work. Why did I boot up Ubuntu? Because I don't know how to code in Windows. You don't need my code slider, right? Do we have some kind of templates here? Templates. This is something you should prepare before the contest. Okay, I have here this thing for test cases. Okay, that's cool. I will need to use it. And anything else? Okay, one single last thing. Is this. And then we are ready to go. I need to later check when this reaches a minute. Reset, start, and let's go. First problem, increasing substring. string, increasing string, longest strictly increasing substring, then that ends at position I. We just need to go backwards from every position, like starting from C, just go backwards because A is smaller and so on. Right, that's just it. The complexity is n times 26. At most 26 times I will go forward, backwards. While s of j minus 1 is smaller than s of j, I will fix the stopwatch in a second. While this j minus minus count plus plus and print the count. New line at the end, we don't need the space here. Copy. Huge array. 1 to 1 to 2 seems alright. Okay. Now quick fix of stopwatch. It seems good. Pending judgment. We will now solve B, I guess. Okay, accepted. That was 2 minutes. During a contest, I would immediately after submitting, I would move to the next problem. Arithmetic array definition, I need to skip that. She can replace at most one element with any integer she wants. Creates a long arithmetic subarray by replacing one element. And it's up to that. Well, when we look at, let's think about some example. Oh, damn it, I modified templates instead of ACPP. That was ACPP. In templates, let's move back to just empty templates file. Copy this to B, and we're solving B. All right. Now, when we have something like this, well, I want to get a long subarray. Let's focus on something starting from here and ending there. When we look at this, can we make this arithmetic by one change? Yes, I can change this 4 to 5. So I need to remove odd one out. I mean, I need to throw the odd one away. If I see 3, 5, 100, 9, 11, 13, then I know I can make this arithmetic by just getting rid of this element. Maybe I should iterate over an element to remove, and then so no matter what this is, I can remove this and just then look at two next elements, or the next element and the previous one, and from this decide what should be the sequence and greedily go left and right as long as possible. Maybe it will be easier if I focus on differences between consecutive elements. I mean, the difference 11 minus 9 is 2, 13 minus 11 that's 2. So I can keep going as long as there is same difference. So I can quickly jump over the same part. Or maybe for every position, like starting from 9, I want to know if I am to take 9 in the next element, then how long can I go to the right? And same thing to go to the left. And then I will consider if I am to remove this middle element, then from 9 to the right, how long I can go. Also from 5 to the left, how long I can go, assuming that those two produce the same difference. Or maybe just I will only take one part. Yeah, I'm quite sure that we need this. For every element, I want to know how long to the right I can go. Let's start coding this. Limits for AI up to 1 billion. For every number starting from, let's say that to right says how many elements I can take. Now, starting from n minus 2 to the right of I is at least 2, maybe more. It's more if the two consecutive differences are the same. Next number minus me must be equal to next number minus next number. This means I have at least length 3. If this, then I just take how long from the right neighbor I can go. Alright, done. I need to do the same in the other direction. So let's make this into a function. Lengths. And I will run this function twice. Like that. Now reverse. To left. And reverse back. And reverse the vector we computed. Alright, for every position I know how long to the left and to the right I can go. Okay, next step. For every position, I will consider this position to be removed. Consider removing A of I. What does it mean? Well, either I can just take what's to the right. If I'm not the last element, maximize the answer with to the right of I plus 1 increased by me, by position I, because I will adjust I. Similarly, if I'm not the 0th position, I can go just to the left, and if I'm neither, and I think there is some extra condition here, then consider answer to be to the left of up to n minus 1 plus myself plus to the right from my right neighbor. So it's like if I have x here, it's how long I can continue arithmetically from 9 to the right, from 5 to the right, to the left, and I sum this up. But this is the condition saying that 9 and to the right versus 5 and to the left, they match. So I need to turn into the average of them. So first condition is that the average of them should be integer. Like if it's 5 and 8, then I cannot make this work. That's the first condition. The next one is that if we have something here and we have something there, the arithmetic difference must be the same. If that element exists and this one does exist as well, and the difference doesn't match, this is the difference I need to have, then, oh, that's not the only thing, continue. There's also a possibility, I see, so that this difference, if it exists, it needs to also be equal to this difference, 9 minus the middle element. Let's do it differently. Let's create a set for differences that I want. In particular, that's difference of my two neighbors divided by 2. That must be the progression of arithmetic sequence. But also, if that element exists, then insert this thing, similar thing on the left, and only if all the differences were the same, then we are allowed to do it. So it means that the average between 5 and 9, how much it's distant from the middle, it must be equal to this progression and must be equal to this progression. I passed the samples. It doesn't mean a lot, to be honest, but if I want to have a good time, not have a good time, if I want to have a nice result, then I need to risk a little bit. I'm quickly looking at the chat. If you have some questions, at me, just use @Ericto, I will then read. The timer is obviously a little messed up. I need to find a timer that I can put like once and not reformat. Oh, wait, only for the second test? What? Oh, sorry, it means that I got wrong answer for the first test. Samples are passed. So I get accepted for this test, but then I pass some hidden test that I don't know. All right. You can see my 3 faces. 4 faces? What? I don't know what you're talking about. If I'm not one of the last 2 elements, and the 2 neighbors, the average of them exists, and then the difference between them divided by 2, this fits in int, so also the division fits. Now if I have at least 2 guys on the right, then the difference between them must match. Here, advent of code speedrun. Advent of code has very long statements, so the speedrun wouldn't be very pleasant. I'm going to test this for n equal to 1, maybe. 10,000 test cases. Okay, first, n is 1, we have 5. Oh, that's the counter test. That was quick. Okay, my code doesn't work for n equal to 1. I can of course think why is that, or just... Oh, I see. I do nothing when... let's just initial answer as 1, because I can always just get one element. This is sad. And already such a plus 4 minutes penalty, it like makes it close to impossible to win the contest. Okay, I will have at least 8 minutes of penalty. Not doing too well. It works here. Again, it works. And it's at least 2. Okay, then it was a very bad resubmission. I need to check before resubmitting if for sure the counter test that I realized is allowed. What for this n? Okay, let me check. N is 5. That was the number of test cases. 2, 2, 3, 4, 5. It's correct, 5. If I'm not first or last, then I can be the middle removed element, and then I want to take stuff on the left and stuff on the right. The average between them must exist as an integer, and I will be equal to that. The diff, so the progression, must be equal to this. So I know what I plus 2 must be and I minus 2, those two, if they exist. The difference between them must be the same as like this average distance. So me versus next one, me versus previous one. Maybe I messed up something here. That's at least 1 always. For every next one. I can have at least 2 as arithmetic progression. If I'm the third last one of them or earlier, and the two differences are the same, then I grab this value. This seems right. 2 left is computed on the reversed vector, then I reverse the vector back and reverse this because this was computed on reversed vector. How about this? N is 6, 1, 2, 3, 4, 4, 9. I got 5. That's correct, right? We changed this into 5. Try this. Okay. 1, 1, 1, 2, 3, 3, 4. I guess that we can change this into 1, or we can take this and change one of those two. Seems fine. Stress testing isn't hard. You need to change one value. Well, if the chat doesn't see a counter test and I don't see a mistake in my code, then I guess I need to stress test this. One more time, I will reread the statement. Contains at least 2 integers. Well, that's a good point, and actually this should be 2, but I'm quite sure that my code will never output 1 for n at least 2, so it doesn't matter. It's not a mistake. This definition is quite vague. Like, what about 2 and 2? I can argue that the differences between consecutive integers are equal. They are equal to 1. N is 5 and then this. Well, you're suggesting something with negative a's, but I don't think it matters. 2 minus 2 minus 6 minus 2 minus plus 1. I got 4. I'm analyzing. Yeah, like this has a progression of minus 4, and then I can change this to minus 10. I highly doubt that you can get 5 here. Looks good. So Fenwick tree, I don't see an issue. N equal to 3. All right. 1 to 3. 1 to 2. Something, something, and something. 3. I know that negative doesn't exist in the input, but still I claim that my solution should work, and I think it works. So what, I already need to do stress testing? I'm glad that I didn't participate in this Kickstart then, because I would be far away from winning. All odds and even cases. I mean, well, let's do stress testing, I guess. But what will be my brute force? For every number, try to, assuming that input has numbers only from like 0 to 10, then I know that the new number will be from minus 10 to plus 20. So that's, I can implement a brute force for this. I will do something risky. I will copy paste my code here to get the reading, same reading, but sometimes the mistake is in the reading of the input data. I think that here it's fine, but if that's the case, then I'm doing a very dangerous thing. For every position, for every value from minus 10 up to 20, temporarily change it and do something here. What do? We check how long I can go. Or for every starting position, we keep going to the right as long as possible. Answer is always at least 2. While the next element exists and the difference is alright. we pass the sample test, time for a generator of small random tests, and values must be from 0 to 10. N is from 2 to, let's say, 5. Print it. Every value will be random value from 0 to 10. Maybe it makes more sense to make them only from 0 to 4. I will quicker find something very special, but this should be fine anyway. I have a script here. I just want to run B versus the brute force. We have a counterexample. My code thinks that the answer here is 3, but actually it's 4. Let's try to find something smaller with in generator. Let n be up to 4 and values up to 6. I should have copied the test. Since you didn't participate here, will you have the ability to reach world finals? What do you mean? I will test this 6, 5, 2, 3. No, this is all right. This should be easy to debug. My code says that it's 3, even though obviously we can replace this with 4 and then all of that is fine. Okay, then time for some debugging. I need to print 2 right and 2 left. To the left starting from here is 2, to the right starting from there is... Oh, right. When I consider this to be the middle element, I say that, okay, I look at the right neighbor, I see that the difference here is -1, and I force this difference I try to use this. That's bad. I should consider that maybe even though there are 2 elements here, I only want to use one of them. That's an obvious mistake. Okay, if all of that, and now I know what the diff should be. The diff should be equal to this. There is some candidate for the answer. Just me, myself, I of I. If I plus 2 exists and the difference is alright, then candidate increase by to the right from I plus 1. Else just increase by 1. This is element AI plus 1 because we can take it. And then same thing to the left. This corresponds to taking a of I minus 1. After I'm done with all the problems, I will get back to this one and talk a little bit more about it. N equal to 5 is the smallest possible n where this is an issue, because I need to remove one element and then look at 2 neighboring pairs. We're at 30 minutes mark. I hoped to already be done with all the problems by now. Accepted now, so yeah, I will get back to this problem after I'm done with everything. But we have, what, 2 more problems to go. And then I will explain some more. Nice stats, a lot of failed tests. All right, open problem, text, now we're doing C. Consecutive primes. And yes, I agree that stress testing for the win. Like, you will spend a few minutes and then you will get a counter test. It's so useful. After doing that in 1 minute, I had a test and I could analyze it. Product of 2 consecutive prime numbers. We get 2020 and the previous such product is this. I think it's easy as long as we have some function to check if stuff is prime, just because primes are quite dense. We'll quickly get it. So you want 2 consecutive primes. This must be around what? Square root of z? I think so. P times p plus 1 is at most z. In particular, for sure, p must be smaller than square root of z. For sure, if it was bigger, then this would be bigger. So we read this. How many test cases? 100. It's fine. Long, int is enough. Round square root of z. Now, while this number is too big, I want this to be true. What do I want to be true? Well, at least that. Just do that. Or not is prime of p. P minus minus. And I claim that this and I need to use a better formula for that. Like with if I get 10 to 18, no, this will be at most few steps. Okay, it's not that for many steps we will get this to be true, because primes are, again, dense. Like once every 100 moves or so, we will get a prime. That's fine. You can Google, there is some article in Wikipedia, prime gap. This thing claims that primes are very dense. Okay, well, this, then p minus minus. And now p is some kind of prime. Do we need to find the previous one and the next one, maybe? Let's do this. It's prime. So it is at least 6. For 6, it will be 2 times 3. Yeah, so it's all right. And then this formula doesn't work. Let's just do this. Now I know that p is too big. Okay, P is one candidate for the prime. I need to find neighboring ones. Maybe unless, let's treat 1 as a prime as well. So let's say that 1 is prime. I think it will be better here, so I would stop at 1 instead of going infinitely long. And now, if I times the next doesn't exceed z, then let's print them. Else. And is it possible that I need to go even further? I don't think that's possible, because p doesn't exceed square root, so p times the previous will be smaller than z, for sure. Okay, correct, but let's see. It's easy to test a few more cases. What happens for 6, for 7, and for the max test? I believe that. Hi, chcę. I would prefer if the chat uses English, but still, hi. Genie is way more complicated than it looks in my stream? Really? What is complicated here? It's very simple ID. All right, last problem, D. There is a graph. City 1 is capital. Simple path is unique. Do they want to say? Oh yeah, it's true. I missed that part. Okay. They want to get from city C to city 1. If you exceed the load, then you pay the fee. Find GCD of toll charges to pay. That's some very artificial problem, for sure. Values are how big? AI is, this is the limit. So we only care about, given C in the query, we only care about edges with this weight Li bigger than something or smaller, and then we take this to GCD. I think we will answer queries offline. The query gives us some city C with some weight, and then on this path, there is this path to the root. Every edge has some limit that the weight w can be up to some limit. Let's say this one says the limit is up to, I don't know, 5. This one says limit is up to 10. And this one says limit is up to 7. And let's say that w is equal to 8. It satisfies this one, but it doesn't satisfy those two edges. They are not satisfied by the limit. And then we take some kind of value ai, and from this one say aj. That's all, and we need to print GCD of that. Segment tree can handle greatest common divisor. And as I said, it seems that offline queries will be nice. What can I do then? I can do a single DFS on this tree, and whenever I'm in some vertex, like I'm in this vertex, I will answer all the queries about this path. So when I'm in this vertex in DFS, I want my segment tree to keep information about this path, about path from the root to the current vertex. Whenever I get one deeper, I get an extra pair that says if you're above, let's say 8, then we take this new AI as towards GCD. I don't know what is top tree. So I will use a segment tree. First, I will sort all the. I will assume that the limits L are from 1 to number of queries or up to n, but that's not the case. Li I think is huge. Then I will first do coordinate compression, or compress the data. And then that will be in some kind of segment tree where it's like there first just let's say 1. Let's say that 1 means a neutral node, or 0. 0 is neutral node, such that GCD with 0 that isn't changed. Then whenever, let's say here for 3, I have information that I need to take here GCD with AI equal to 8, then I will put 8 here. And there is segment tree built on the top of that. And segment tree allows me to grab GCD of some prefix. Like for 8, I need to take GCD of prefix corresponding to values like 5 and 7, because those don't allow me to exist. How do you sort DFS paths with MOS? Well, I'm not going to use MOS algorithm. Let's implement this. And hopefully I will finish before 1 hour passes from the start of the contest. This is D, some complicated input, and Q. I will have a lot of global data, so I'm going to put this in a struct. Not to, forget to clear something between tests. Right. There is NQ. Then roads. X and Y are from 1 to n. Well, here it's specified, but in limits they should say that x and y are between 1 and n. Okay, x, y. They should use 10 to 9th. I no need to use longs. Li. What's the limit for Li? This is the limit for Li. Oh, I don't need to compress. That's very pleasant. So this is just what needs to be kept in a segment tree, but I don't have this element of data compression. Cool. You should ignore what it means in my templates, but it prints name of a variable as well. Will this work? No, it will not, because that's what now? Everything needs to be long. There is the value L, and then there is long A. So push back an edge, YLA. Do this, then the initial DFS, no, just directly the main DFS, starting at the root and with no parent. DFS starting here and with some forbidden parent for every edge. We go here, need to go down. No, the A is name of a node. Then let's call it G for GCD. So G is this huge value from 10 to from 1 to 10 to 18. But before I do DFS, I need to read queries in order to solve the problem offline. There's C and W, both are ins. C represents a node. Queries of C, push back, and now it's, I guess, just the pair. This query ID and this W. Queries are from 0 to Q-1. Can you share your template? Go to code forces and grab any of my submissions. There is query, so those are vectors of queries. Here we will do something. When we are at A, I answer all the queries ending at A. Answer, what is the answer? At the end we obviously print it. 9.5 minutes left if I want to have 1 hour time, not counting the wrong submissions. Query set but not used, that's just the warning. Okay, we only have warnings. For every query, I will grab some prefix of a segment tree. And here, when I see this, I will update this node of a segment tree. How many? Here, do this thing. I think I will have a whole segment tree to avoid data compression. I will just have a segment tree with this base. This will be global to avoid creating it over and over again. So we have this, and here just at this position, at position length, I would need to put G. Tree of base plus len G, and update the path to the root. In some version of GCC, you cannot take GCD of 0 and something, but I just for now hope that this will work. This is long, cool. At the end, I will need to clear this, and I think that this should be fast enough. But if not, I know how to speed this up to be linear of, or maybe n log n of the input data. All right, now for query, I need to do something for a prefix. If I have query.w equal to 10, then let's see. If the weight of the load is greater than or equal to a load limit Li. So if equal, then also I need to count it. So now, given AI, I need to find all LIs that are smaller than or equal to AI. So everything up to this in the segment tree. Up to this. Well, let's take tree of base plus query.w. Now some standard stuff from a segment tree. And this code computes GCD in a prefix. Close. Let's just say that this is close. Here we use spaces. One, 2, 0, 5, 7. Those two answers are wrong. I will do my own GCD maybe. Because I don't know if the built-in one works for zeros. I think it should, but just in case. Is that all? When we go up, back, I need to cancel this. Of course. Works now. Now this part, it will be 100 times size of a tree. What's the time limit? Oh, 20 seconds. Yeah, that's obviously right. That's not an issue at all. G++ has both GCD and underscores GCD. Okay. I'm not wrong to use this one. I'm reading the chat now. Hey, correct. The goal is kind of achieved. I'm below 1 hour. 2 wrong submissions for the second problem, which was indeed tricky, just like the chat told me. I would be, let's see, hour and 4 minutes, because my time plus 8 minutes of penalty. I would be here. That's 19th place. But I think that without explaining stuff, I would save those extra few minutes. So I think I would easily be top 10. Okay, 58 minutes wouldn't be a problem to beat. Because I would need to be, let's see, I'm 56 plus 8. I would need to be 50 minutes instead of 56. For sure, on just explaining stuff, I wasted that much. So let's agree that I'm top 10, okay, around 10th place. For sure, I'm not anywhere close of first or second place, just because of how much time I wasted on B. But third place was achievable, and for sure I'm in top 10. Congrats. I don't think that's worth congratulations. If you look at my Codeforces writing or just, achievements, I should be in top 3 for sure. So this kind of result is bad simply because I wasted a lot of time on B. Kickstart has the same difficulty as Division 2 round? I don't know. You can compare their times for top people to judge it yourself. Galen is sad you made him 11th. No. I cheated because I participated after the contest, so I'm not really top 10. I'm not even top 1000 because I didn't participate in the contest, because it was 1 a.m. I thought, by the way, that it will be 11 p.m., but I looked at time zones incorrectly. So I wanted to participate in this contest. It was close to 11 p.m. I opened my computer and realized that, 2 hours left till the contest starts. So I went to sleep. Optimal way for preparing for Google Code Jam Round 2. Solve past problems from Google Code Jam Round 2. I promised you that I will talk about a little bit more about my code here, about my solution. So 2 things. First the solution, and then we will go together through the code. If you don't know, first the statement. You're given a sequence, and you can change at most one number to some integer. The new number must be an integer. You want to get as long subarray with arithmetic subarray dot. That's it. End of the sentence. Like here, 9753. This is already arithmetic progression. So the answer is 4. You have subarray of length 4. If instead of 7 we had 50, still the answer would be 4, because we are allowed to change at most one number. Here, I think the answer will be at least 6. This can be turned into arithmetic progression just by changing 4 into 5. This is the statement. This is the second problem out of 4. The last task was track delivery, the one with a tree. Okay, so this is the statement. Now, what's my solution? my solution is this. There is this sequence. For every number, I want to consider that maybe this one should be removed. Okay. And let's look at maybe the next number. Say here we have 5. And this one can be adjusted to whatever I want. Let's say that here we have 8. What does it mean? It means that this one needs to be adjusted to 2, no matter what other values we have. This one needs to be 2 if I want to combine this. And as long as here we have progression of +3, then I can continue taking to the right. If for every possible removed element I will keep going to the right linearly, the total complexity in that case would become quadratic. That's bad. I don't want that. We want to be faster than this. So instead, this part of how many steps to the right I can take to keep the same difference, like here +3, I want to pre-process that. And I do it as pre-processing from right to left. If I see somewhere that there is 5 here, 8 here, and here 11, and I know that starting from this position I could go to the right and take 60 steps, then obviously I know that starting from 5 and going to the right, I can make 61 steps. So if this difference is the same, 11 minus 8 versus 8 minus 5, then the number of steps to the right I can take starting from here is the previous number of steps plus 1. Otherwise, so if, let's say, this is 12, then well, I can't take 5, 8, and 12 as the right part, because this I need this preprocessing just to say what happens if here I erase this element, or actually I change it to something else. In this case, I just say that starting from 5, I can only have 2 elements, or 2 steps, whatever. But if this was 11 instead, then I would take the number of elements I know I can take starting from here, plus 1. I do the same thing from left to right in order to know, starting from this position, how many elements I can take to the left. I pre-compute those 2 arrays, and I call them to the right and to the left. For every position, I know how many steps I can take in both directions independently. Now back to the top drawing. Let's remember that I'm considering changing this element to something new. And what do? I need to verify if this difference here, 5, 8, is the same as the difference on the left, but that's not enough. Let's say that this is 3 and this is 0. From here, it seems that I would need to change the middle element to 4, because that's the average of 3, 5, but then we don't have an arithmetic progression. If I want to grow in both directions, to the right and to the left, what needs to happen is that this difference is the same, 8 minus 5, and this difference is the same, this element minus this one, and also the difference that would appear here needs to be the same. An example of that is, let's say, 9, 7, 3, 1, because then for sure in the middle we can have 5, this should be the new value I changed to, and then every single difference is the same, and I can take from pre-computed arrays how much I can grow from 7 to the right, how much I can grow from 3 to the left. And I say this number of those elements plus 1 plus the number of those elements, that's the possible answer. I should update today. I believe you. What's today? Sick and lazy? No, okay, that's not true. Okay, I erased today. Today is now not a working command. I should ban cfcoder. Oh, obviously. What is this spam? Okay, banned. No, there isn't any command for tomorrow or yesterday. now today will not work. It will not give you anything. Okay, so this is the main example, the main case where we remove something and we are surrounded by stuff, so we will keep some part of subarray both in the right and in the left. But it's also possible that 5 is like the very first element of subarray to take. So if, and this was my mistake, if here on the left we have some unmatching element, like let's say 100, then it's not that this is bad candidate to be changed. No, it's just that we will take this part to the right, myself, and a 3, if we can take 3. So this is the case where the answer is, if this is position I, this is I, then the possible answer here is 1 plus 1 plus to the right of I plus 1. The first one corresponds to this element, the 3. This one corresponds to this red changed element. And then to the right of I plus 1 just says how many times I can go to the right starting from 7. How many elements I can take there. Similarly, if after 7 we have here instead of 9 some bad number, or just this is end of the array, then this I would replace with 1. So any kind of combination like this is possible. But the perfect case is of course this, if we have all the equalities that we want. Yeah, this is the solution, and now let's go through the code. This function is supposed to, can I change the size here? No, I can't. This function is supposed to find the number of elements I can take to the right. So I go in backwards order, starting from position n-1. There, the number of elements starting from n-1 is just 1. Then for every next position, I here say if I have 2 equal differences in a row, like 5, 8, 11. 11 minus 8 is equal to 8 minus 5. I check that here in an if. If that's the case, then how many elements I can take starting from here to the right is number of elements from I plus 1 plus 1. If from 8 I could take 20 elements, then from 5 I could take 21 elements. This is the function, and it returns this vector. To avoid some extra coding, I run this function twice. It's somewhere here. I read the input, I run the function and save the vector as to the right, to right. Then I reverse the input, run the function again and call it to left, and then reverse it back. Those 2 lines were just for debugging purposes. And then the main part. For every position, I consider this position to be removed. This is easy, but I consider what happens if this is the first element or the last element of this subarray. So I only look to the left or only look to the right. But this is real fun, where I first check. This now cannot be the first or last element, cannot be position 0 or n-1, because I want this to be in the middle. And the 2 neighboring elements, their average needs to be even. Like if we have in a row elements, let's say 8 and 14, those are my neighbors, then I'm fine because I can be 11. But if my neighbors were 8 and 13, then in the middle I couldn't put any integer. There was condition in the statement that every number needs to be integer. The new number needs to be integer. So in this case, that's not possible. 8 plus 3, this sum needs to be divisible by 2, because their average needs to be an integer. I check that here. And only if my 2 neighbors have the same parity, or the sum is even, then I compute what the difference must be. That's like the difference between those divided by 2. So here, the difference is 6, so the difference between every 2 consecutive elements must be 3. And then I check that stuff that I described here. Like if now I compute a difference equal to 3, so I check if 9 minus 7 is 3. I check if, I need to draw this. AI plus 2 minus AI plus 1. I check if this difference is equal to the diff. We will for sure see this in the code. Yeah, if this is equal to the diff. And I plus 2 must exist at all, so I check if I plus 2 doesn't exceed n. Can I explain my template? No, I will not, but you can see this code forces Warsaw templates. This is complicated. I will not go through this now. Don't use my template, it's stupid. Right, that was summary of problem B, longest progression. Do you have any other questions about the problems and my solutions? Problem D is a problem where if you don't know this technique I used, then it will be hard for me to explain it. No, so I don't want to spend much time on D. Like, problem B is approachable. This one was about doing some logic. You don't need to know hard algorithms or data structures. For track delivery, you need to know that. If you know that, then you understand the solution. If you don't know that, then we would need to now spend 1 hour. Open Eknerwala's submission. For which problem? For this one? I guess something very easy. That's not very easy. For D, okay. Nice. But I guess that most of that is copy-pasted. It's the first time I hear name top tree. This is Eknerwalov's submission. We have some link. Is it related to linkat? Compress. Okay. Flipping paths. Splay. Okay, splay says something. Very interesting. And now we have main. I guess he just realized that he knows some data structure where he can ask about path from the root to anything, and he just used it. Also, in first seconds, I thought maybe it's heavy light decomposition. If I had some code to copy paste it, then maybe I would just use it. I'm not going to understand what is happening here. I don't really use linkat trees or splays. I only know how to implement BST from scratch. So I mainly understand that one and I use that one. All right. Well, for almost 500 lines of code. I'm sure that organizers didn't expect that. But then you open the editorial and it seems it turns out that this is the intended solution. That would be funny. Seems better than LCT. Right. Well, I will take a quick look. This is top trees. Maintain a balanced binary tree of logarithmic height. Link, cut, expose. Boundary vertices of the top tree. We have merge, split. All right, some complicated data structure, sure. What is my name in Kickstart? I guess if I participate, my nickname is Ericto, like here, EriCHTO, but I didn't participate in this round, so you will not find me. I mean, I participated now, but it's only after the contest. I'm not in the leaderboard. Cool. All right. This is time to end the stream. I will see you next time, I guess on Thursday, standard time, same as today. If you have more questions, suggestions, join the Discord server. And I hope you enjoyed this and you learned something. I'm sad that I didn't participate in the actual round, but again, it was middle of the night for me, and I'm old enough that I value my sleep and my sleep schedule. Oh no, I just joined. Well, sorry about that. But on YouTube you can watch all the past recordings. And the advantage of watching the past stream is that you can, skip some boring parts, make it faster. This is how I would watch some streams that I missed. I would just run it out on ×2 speed, maybe slow it down whenever something interesting is happening. 8 hours of sleep is a must. It's for sure a nice thing to have. Neil nailed the round. So I think that Neil started a few minutes late, right? He didn't start with the very beginning of the contest. 7 minutes late, exactly. So his actual time should be 20 minutes, not 27, and that's a very nice time. So congrats to him. He was very, very fast. We can later check. I will add timestamps to the YouTube recording, and we'll see how much time I spent on every problem. The first one was whatever, it was 2 minutes. But then I think that in B I spent more than half an hour. I'm not sure about my times for C and D. For C I spent like 2 minutes more than I should, because I thought, like, should it be square root or square root like rounded to some place? I wasn't sure if p times p plus 1 is the good bound or just p times p. So Neil really nailed the round. Congrats to him. And it was indeed standard, but Google Kickstart is a standard contest. It's a contest not for pros. It's not a contest for grandmasters from Codeforces. It's meant to be, I guess, an introduction towards Google Code Jam. Peanut butter raw, it's fine, yeah. But you cannot eat too much of it. Like, if you eat a lot of it, you will feel very bad unless you drink milk along with it. All right. Further questions, go to Discord. This is not how you spell Discord. And see you next time. Thanks for watching. Bye.